Morning. Today I'm going to go ahead and give you the answers and work them out for you for the inequalities, just so you'll have this before your test and you can go over that. So let's look at number 29, okay? This is the kind that's already factored. It's pretty much already solved because it's been factored. So we know what our solutions to this equation are. We know that the x-intercepts are actually our solutions if we were going to graph that. So we've got x equals 3, x equals 4, and then anything that's going to be a point of discontinuity is also going to be part of what we're going to test. So x equals 5 and x equals 6. So we're going to make a number line. Go ahead and make your number line. And make some little marks here for 3, 4, 5, and 6. All right, because those are all either your solutions or your points of discontinuity that are going to cause problems for you. So let's go and see what we can do with that. Now, really, all you're going to do is test some things in between these numbers. So I'm going to pick some numbers that are very easy to deal with. So a number that is smaller than 3, that's very easy to deal with, in this case would be 0. Anything between 3 and 4, I'm going to pick 3.5, 4.5, and 5.5. And then you have to pick something on the outside, so I'm going to pick a whole number because it's easier. Let's go ahead and pick 7. All right, so I'm going to test these. Now really, all you need to do is know the sign. You're going to plug these numbers in for x. So I'm going to take this equation and I'm going to plug a 0 in for x. So I'm going to get negative 3, because 0 minus 3 is negative 3. Negative 4, because 0 minus 4 is negative 4. Negative 5. And now negative 6 is going to be squared, so that's actually going to be a positive 36. So once we get all that together, we get a positive over a negative, and that is definitely less than or equal to 0. So yes, it works with the range or the interval that's less than 3, less than or equal to 3. All right, let's go and see if we've got, let's see, let's go test 3.5. Now I am not going to work all that out so much because that should be pretty simple. 3.5 minus 3 is going to be positive, but 3.5 minus 4 is going to be negative. 3.5 minus 5 will be negative, and anything squared is going to be positive. So this is going to be a negative over a negative, which is positive. So positive numbers are not less than or equal to 0, so not that one. All right, let's go and check the next point. And then you're just going to go through and try all of these. I'm going to go through and work them out because I don't want to run out of time on here. So I'm going to work them out, but you're doing the same thing. You're just going to test the points. Okay, so I've gone and I've tested 4.5 and 5.5, and that's what I got. So I'm going to test the last one. 7 minus 3 is 4, so that's positive. 7 minus 4 is 3, so that's positive. And again, I'm plugging 7 into all of these x's here. Okay, 7 minus 5 is positive, and anything squared is positive. So the answer is going to be positive. So that will not work. Okay, so what do we do with that information? Well, you're going to write your solution as an inequality. Okay, so we're going to go ahead and now this would be all the way to negative, and not negative 8. I'm trying to do an infinity. Negative infinity. Okay, so yes, it works from negative infinity, and it includes, well, you never include negative infinity, so I should take that off. Okay, there's one of your solutions, because we don't include infinity. There's one solution, so that's this one right here that we just did. Okay, we had another solution right here. So our next solution is going to be from 4 to, it cannot include 5, can it? All right, so you got to be very careful not to use the less than or equal sign with the 5, because look, if you put 5 in the denominator, it's going to make it be 0, and then we know that's not allowed. So make sure you just make it a less than sign. All right, I'm going to go ahead and do number 31. Okay, so let's look at number 31. First, you want to solve it. Okay, so you need to solve these kinds because you've got variables just in the denominator and it's not factorable. So let's go ahead and solve it. Our common denominator looks like it's going to be 8a. So I'm going to put an 8a in all of my denominators. And then we're going to figure out what the numerator would be. So I'm going to go do that while I pause it. Okay, so I pretty much wrote down what I need to multiply each part by. So 1 times 2 in the numerator is going to be a 2. 5 times 1 is 5, and then that becomes a 4a. Now that all of these guys are the same in the denominator, you can drop it. And you go ahead and solve your equation the way that you would normally solve an equation. Let me drop this denominator here. Drop that denominator, and we're left with 2 plus 5 is 7, 7, I'm looking at the 4, is greater than 4a, so obviously 4a, I'm going to switch this around with a symmetric property, a is less than 7/4. Okay, so that's one of our solutions. Well, that is our solution. All right, we just need to look to see what is going to be what is x not allowed to be, or what is a not allowed to be. Now, in this case, a is not allowed to be 0. Okay. Now, that's basically it. But let's go check to be sure, because we want to make sure that our regions are okay that we're looking at, or our intervals. So I'm going to put 0 here, and then 7/4 is not quite to 2. Okay, so 7/4 is kind of in between 1 and 2. Not quite to 2. So let's go and check some areas. So anything less than 0, I like -1. Anything greater than 0, I like 1. And then anything greater than 7/4, well, 2 is nice and easy. So let's check these different regions. I'm going to plug these in. Let's plug in -1 first. So we get 1 over -4 plus 5 over -8. Is that greater than 1/2? Well, you can go and change them and make all your denominators the same. Blah, blah, blah. Okay, 2 over -8 plus 5 over -8. That's 7 over -8. Well, anything that's negative is negative, and it's not positive, so that's not true, so that doesn't work. All right, so then we go and check 1. 1 is going to be nice and easy. 1/4 plus 5/8. Is that greater than 1/2? Well, 5/8 is already greater than 1/2, so I'm thinking yes on that. All right, and then we're going to check 2. So 1 over 4 times 2 is 8, plus 5 over 8 times 2 is 16, greater than 1/2. Well, let's look at that. That could be. So go ahead and calculate that out. That's 2 over 16 plus 5 over 16. Is that greater than 1/2? Nope, that's 7 over 16 is not greater than 1/2, so that does not work. So you've only got one interval that's going to work for you. All right, so obviously we're going to name our interval solution is going to be between 0, well, and it cannot be equal to 0, right? And that's an A, and 7/4. And it can be equal to 7/4. No, it can't, because it's never equal to it. All right, so don't put that equal sign there. Hold on. All right, that's your solution set right there. All right, and if you need to, just go back and make a note and make sure that it is understood that A cannot be 0. Okay, so there you go for that one. Let's go on to the next one. 33. Okay, this one's a little bit easier, so we're just going to go and solve this out. I'm going to solve it real quick. You have to have a denominator of y plus 1. All right, once I got my denominators the same, basically I needed this to be a y plus 1, so I multiply that by y plus 1, and you get that. Now that your denominators are the same, you can drop them. So I'm going to drop them. and you get something like this. I'm feeling like this is going to be 0 or something, but I'm not sure. So 7 is greater than 7y plus 7. Yep, I'm thinking this is how it's going to go. It's once you subtract 7 from both sides, you've got 0 is greater than 7y. And it doesn't matter what you divide by, 0 divided by anything is still 0. It's not undefined. So y is less than 0. All right, so that's one of our solutions. Well, that's actually our solution, but we've got to go back and check. So we're going to go, and we have one more point that it's not allowed to be. Y is not allowed to be -1. So let's go and make our intervals. I will let you do that and check that, and I'm going to pause. Okay, so I've got my intervals. I'm going to pick a number that goes between those or outside of that. I'm going to go with -2 for this. We can only go between -1 and 0, so I'm going to have to go with -1/2. And then anything greater than 0, let's go with 1. That's easy. Okay, so we're going to check these numbers in here. So 7 over -2 plus 1, is that greater than 7? Nope, it's not. That's 7 over -1, that's -7. And nope, that doesn't work, so no. All right, throw in 1/2 and see what we get. Now that gets a little complicated because you're going to be dividing by a fraction, all right, which means you're multiplying by its reciprocal. So 7 over 1/2 is really 7 times 2. All right, if you don't believe me, put in your calculator, see what happens, or it's really 7 times the reciprocal of that. That's 14. 14 is definitely greater than 7, so yes, that works. All right, and then the next one is going to be 1, and that's easy. 7 over 2, is that greater than 7? No, it's not. So our interval that we have for a solution is between, what is it? It is going to be between -1, cannot equal -1, so we're going to do strictly a less than, and then we've got y, and then less than, where are we? 0. Okay, that's your solution for that. Let's do one more. So I didn't get to go to this one yesterday, so those of you who are absent today, this is how we're doing this. This is really not a word problem, okay? Ratio means you write these as a fraction. You write this on top, you write that on bottom. X plus 2 over x minus 5 greater than, greater than 30%. Well, that's 30 over 100. Let's put that down in lowest terms. And I'm thinking that's 3 over 10. So let's go put that as a 3 over 10. And then you solve it. So find your common denominator and solve the equation. And I'm going to go let you do that real quick. All right, so the common denominator is 10 times x minus 5. I went through and I worked all that out. I'm going to drop my denominator. All right, through the magic of the pause button. Now we're going to distribute. So we've got 10x plus 20 is greater than 3x minus 15. Go ahead and solve it. You get 7x is greater than -35. We didn't multiply or divide by a negative, so we didn't have to split the inequality. So we've got x is greater than -5. All right, so let's go write our solutions up. I'm going to pause this. Okay, so x is greater than -5, and then we can't forget what's going to make this be a problem. So x cannot equal 5. So we go and we make our number line. Here's one at -5. Make another number at +5. Let's pick a number in between all of these. I like some of these because these are going to turn them into nice, easy numbers. This one won't, but whatever. Okay, so put in a -6. And you're going to get -6 plus 2 is going to be a -4. And then a -6 minus 5 is -11. Well, that is +4 over 11. Is that greater than 3 over 10? Not sure. Let's calculate that. Okay, so it's 0.36 repeating. So yes, it is. It's working. All right, and let's put in a 0 for x. So let me erase some of this real quick. Okay, so putting in a 0 for x gives us 2 over -5. Is that greater than 3/10? No, it's negative, so it's not going to work. Let's put in a 6 for x. So once you put in a 6 for x, okay, putting in a 6 for x made it 8, so that works. So we've got our answers there. I'm almost out of time, so go ahead and write your inequality, and I'll show you that in class.